I hope all of you are doing good. Let's start today's chapter, factors and multiples. Okay, see, study the following table. In the above table, each row of numbers corresponds to the multiples of the number in the first column. Multiples of numbers from 2 to 10 are seen in the table. Okay. And from the grid we observe that certain numbers are multiples of more than one number. For example, 8 is a multiple of 2, but it is a multiple of 4 and 8 itself. Consider 5 into 8 is a 40. So this shows that 40 is a multiple of both 5 and 8. Similarly, if we consider 2 into 1 is equals to 2 and 4 into 1 is equals to 4, it shows that 2 is a multiple of 2 and 1 and 4 is a multiple of 4 and 1. So from the above we conclude that every number is a multiple of itself. 2. Every number is also a multiple of 1. 3. A multiple of a number is always greater than or equal to the number itself. Even and odd numbers. We know that the multiples of 2 are 2, 4, 6, etc. These numbers are even numbers as they leave no remainder when divided by 2. A number is called an even number if it is a multiple of 2. As the numbers 1, 3, 5, 7, etc. do not appear in the multiplication table of 2, they are not multiples of 2. A number is either even or odd. Numbers which are not even are called odd numbers. So now consider the given table. Okay. 1-digit numbers, smallest even number is 2 and greatest even number is 8. Smallest odd number is 1 and greatest odd number is 9. We are talking about 1-digit number only. Okay, next 2-digit number, smallest even number is 10, greatest even number is 98, smallest odd number is 11 and greatest odd number is 99. Okay, similarly 3-digit, 4-digit, 5-digit and 6-digit numbers are also given here. Okay, exercise 8.1. Consulting the grid on the previous page, write the 7 multiples of the following numbers. Okay, you have to write the multiples of 6 and you have to consult the grid on the previous page, which is this. Now you can see the multiples of 6, 6, 12, 18, 24, 30, 36. Okay, so write down the multiples of 6, 6, 12, 18, 24, 30, 36 and 42. 1, 2, 3, 4, 5, 6, 7. These are the 7 multiples. Okay. Factors. Consider the following. 7 into 8 is equals to 56. We know that. 56 is a multiple of both 7 and 8 and both 7 and 8 are factors of 56. Similarly, 6 into 9 is equals to 54. 54 is a multiple of both 6 and 9 and both 6 and 9 are factors of 54. 5 into 7 is 35. 35 is a multiple of both 5 and 7 and both 7 and 5 are factors of 35. So from the above we observe that when we multiply any 2 or more numbers, we get a product. The product is a multiple of each of the numbers multiplied. Each number is a factor of the product. Okay. Prime and composite numbers. Prime numbers. Numbers having exactly 2 different factors, namely 1 and itself, are called prime factors. Always remember that a prime number has only 2 factors, 1 and the number itself. Okay. Consider the number 2. It has no factor other than 1 and 2. So 2 has exactly 2 factors. Therefore, 2 is a prime number. Similarly, these numbers are also prime numbers since these numbers have only 2 factors, that is 1 and the number itself. Okay. Composite numbers. Numbers having more than 2 different factors are known as composite numbers. Clearly, the factors of 4 are 1, 2 and 4. So, therefore, 4 is a composite number. Similarly, each of the numbers like these numbers, these are the composite numbers. The number 1 has only one factor, namely itself. Hence, 1 is neither prime nor composite. Okay. To find prime numbers between 1 and 100, we write down the numbers from 1 to 100 in rows of 10 as shown below. Okay, your numbers are written from 1 to 100. So there is a simple rule for finding prime numbers. Eratosthenes, a Greek mathematician, gave a method for finding prime numbers by removing numbers that are not prime. His method is explained below. Number 1, cross 1 because it is not a prime number. Then cross 1-digit prime numbers, that is 2, 3, 5, 7. then cross every multiple of 2 other than 2. Then cross every multiple of 3 other than 3. Then cross every multiple of 5 other than 5. Then cross every multiple of 7 other than 7. Exercise each one of the remaining numbers. Okay. The numbers encircled are prime numbers. They are, let's see, these numbers are prime numbers. Okay. Now, twin primes, 2 prime numbers whose difference is 2 are called prime numbers. Okay. For example, 5 minus 3 is 2. Okay. So, 3 and 5, these are the pairs of twin prime numbers. Similarly, 5 and 7, okay, 11 and 13, 17 and 19, these are the prime numbers between 1 to 100. Okay. Now, prime factorization. Writing a number as a product of its factor is called factorization. A factorization in which every factor is prime is called the prime factorization of the number. Let us take an example. Prime factors of 24. See, 1 into 24 is 24, 4 into 6 is 24, 12 into 2 is 24. 2 into 12 is 24, 6 into 4 is 24, and 24 into 1 is 24. 3 into 8 is 24, and 8 into 3 is 24. So, all the factors of 24 are 1, 2, 4, 6, 8, 12 and 24. Out of these, the prime factors are only 2 and 3. Now, express 84 as a product of prime numbers. Divide 84, you will divide 84 by the smallest factor 2. Okay, if you divide by this by 2, you will get what? 42. Okay, what will you get? Divide. Now, next divide 42 by the smallest factor 2. Again, you will divide 42 by 2. So, what will you get? You will get 21. Next, divide by the smallest factor 3. Okay, you will divide 21 by 3, you will get a 7. Okay. Next, divide 7 by 7. If you divide 7 by 7, you will get a 1. So, the prime factors of 84 are 2 into 2 into 3 into 7. This factorization may be shown by the following diagram known as factor tree. This is the factor tree. Okay. How do we show this in the factor tree? 84. Okay. So, we will write 2 into 42 is 84. Then 2 into 21 is 42. 3 into 7 is 21. Okay. No need to write 7 into 1 is 7. So, these are the prime factors, 2 into 2 into 3 into 7. Okay. Exercise 8.2. Find the factors of 18, 32, 28 and 42 through division. Okay, you have to find out the factors of 18. First, you will divide it by 2, you will get a 9. Now, you cannot divide it by 2, so you will divide it by 3, you will get a 3. Then 3 divided by 3 is 1. Okay, now the factors of 18 are, what are the factors? 1, 2, 3, 9, 18. Okay, similarly, you will find the factors of these numbers through division. Okay, test of divisibility. The word divisibility relates to division without actually doing division. Test of divisibility help us to take a look at a number and find out if it can be divided by 2, 3, 5 and so on. Test of divisibility also helps us to find out factors of a number. Let us take a look at the following test. Test of divisibility by 2. A number is divisible by 2 if its unit digit is even. Okay, thus a number is divisible by 2 if its unit digit is any of these, that is 0, 2, 4, 6 and 8. Example, all these numbers are divisible by 2 because all these numbers are even number. Next, test of divisibility by 4. A number is divisible by 4 if the number formed by the last 2 digits on the extreme right is divisible by 4. Consider the numbers 212, then 436 and 256. So, we will consider only the 2 digit from the right side. Okay. So, 12 is divisible by 4, 36 is divisible by 4 and 56 is also divisible by 4. Okay. That means this number and these 3 numbers are divisible by 4. Next, test of divisibility by 3. A number is divisible by 3 if the sum of its digit is divisible by 3. Consider the number 723. So, what will we do? We will do the sum of digits. Okay, 7 plus 2 plus 3. 7 plus 2 is 9, 9 plus 3 is 12. Is 12 divisible by 3? Yes, that means this number is also divisible by 3. Okay, similarly, next number is 3, 4, 5. 3 plus 4 plus 5. 7 plus 5 is 12. 12 is divisible by 3. That means this number is also divisible by 3. And the next number is 219. If we add the numbers, digits, we will get 12. That means this number is also divisible by 3. Now, test of divisibility by 6. A number is divisible by 6 if it is divisible by 2 as well as 3. Thus, a number is divisible by 6 if its digit in one's place is even and the sum of digit is divisible by 3. For example, 852. Okay. 852, 2 is at units place. It's an even number, it is divisible by 2. Okay. Now, let's find out whether this number is divisible by 3 or not. Let's do the sum of the digits. 8 plus 5 plus 2. 8 plus 5, 13 plus 2, 15. 15 is divisible by 3. That means this number is also divisible by 3. Okay. Now, this number is divisible by 2, divisible by 3. That means this number is also divisible by 6. Okay. Next, test of divisibility 5. This is very simple. A number is divisible by 5 if its digit in one's place is either 5 or 0. Okay. For example, these numbers are having 5 at units place, 0 at units place, here 5, here 0. So, all these numbers are divisible by 5. Okay. Test of divisibility by 10. A number is divisible by 10 if its digit in one's place is 0. For example, all these numbers are divisible by 10. Next, test of divisibility by 8. A number is divisible by 8 if the number formed by the last 3 digits on the right of the number is divisible by 8. Last 3 digit. Okay, so 4304, we will consider only last 3 digit. Okay, so let's divide this number by 8. So, 8 3s are 24, 6, then 4. 8 8s are 64. Okay, this number 304 is divisible by 8. That means this whole number, that is 4304, is divisible by 8. Okay. So, whenever we are checking the divisibility of 8, we will consider 3 digits from the right side. Okay. Next, test of divisibility by 9. A number is divisible by 9 if the sum of its digit is divisible by 9. For example, 81. 81, let's find the sum. 8 plus 1 is 9. 9 is divisible by 9, that means 81 is also divisible by 9. 387, 3 plus 8 plus 7. 3 plus 8 is 11 plus 8 is 18. 18 is divisible by 9, that means this number is also divisible by 9. Okay. Now, let's do exercise 8.3. Factorize the following numbers to find out if they are prime or composite numbers. Take the help of test of divisibility. Okay. So, we have this number 23 and 25. 23. 23 is what? 1 into 23 and 23 into 1 is 23. Okay. So, clearly 23 has only 2 factors, that is 1 and 23. So, 23 is a prime number. Okay. Now, 25. 25 is what? 1 into 25 is 25. 5 into 5 is 25. Now, number of factors 1, 5, 25. Since 25 has more than 2 factors, therefore, it is a composite number. Okay, students? Now, you will do practice of the remaining questions.